Where is our galaxy heading? What do the cosmic microwave background radiation and distant quasars say about our movement? Why have new studies in this area puzzled scientists? And what does the great attractor and the dark flow have to do with it? Let's figure it out. In the last video on this topic, I did not come to any definitive answer. But I have made one very important assumption that is the best way to describe what is happening. For those who have not seen or have already forgotten this video, I advise you to check it out. This video is number 5 in the playlist. I will briefly tell the story of this riddle. But so as not to confuse you, I will tell it with some chronological violations and without details. Because the most important thing is that you catch the logical chain itself that has reached a dead end. For a long time, astronomers began to notice that on one side of the starry sky, quasars and distant galaxies have a blue Doppler shift, and on the other side a red shift. This distribution with two poles is called a dipole. The Doppler shift at these poles is maximum, and in all other directions it is intermediate. And such a dipole distribution is most logically interpreted as our movement in space, towards the pole with a blue shift. Such an interpretation of this dipole is called kinematic. And at this stage there are no problems in interpretation, everything is simple and clear here. Studies of cosmic microwave background radiation confirmed this dipole and calculated quite accurately our speed of supposed motion in the universe. This is approximately 600 kilometers per second. In general, after studying the cosmic microwave background radiation, the idea appeared that the cosmic microwave background radiation can be used as some universal global reference system, taking into account the expansion of the universe, of course. And the cosmic microwave background radiation is perceived by many precisely as a global reference system. And the CMB dipole is interpreted as our movement in the universe. But a study of the local group of galaxies and nearby galaxy clusters has shown that the local group of galaxies, our galaxy, the Andromeda Galaxy and a group of other small galaxies, are presumably moving towards the Virgo cluster. And the direction of this movement is very different from the expected movement relative to the cosmic microwave background radiation. And this is where the problem arises. Because relative to nearby galaxies, we move in one direction, and relative to the cosmic microwave background radiation, we move in a different direction. How can these two movements be combined and explained? And here, in order to correctly understand the problem and its solution, I want you to conduct a thought experiment. Imagine a huge room without lighting or windows. There are many objects moving chaotically in this room, and you are one of these objects. Each object emits a signal at a certain frequency. And by the shift of this frequency, you can determine the movement of these objects relative to you. There is also air in the room, relative to which you can determine your own movement. Some analog of cosmic microwave background radiation. You analyze signals from all objects, find a reference system relative to which the total speed of all these objects is 0. In other words, find the conditional rest frame of the entire system. And if the velocities of these objects are distributed isotropically, then this reference system will be motionless relative to the room in which all this is happening. And having found this reference frame, you calculate your motion relative to it. And if you are really moving in this direction, then you should feel the wind from this direction. But the wind is blowing from the other direction. And there is only one way to explain this. Assume that the assumed frame of reference at rest has motion. This means that all objects of the system have an additional general movement in one direction. And it was this logic that led us to assume that all galaxies and galaxy clusters close to us are moving in the same direction. This is how the dark flow appeared. The name dark comes from the analogy with dark matter and dark energy. Dark, in these cases, means that the phenomenon has no explanation or very little is known about it. This movement is also called the local flow of galaxies or simply the bulk flow. And here I must make a clarification. That exactly the phenomenon called the dark flow was discovered through the kinetic Sunyaev-Zeldovich effect. But this is precisely the moment when the details can become confusing. This amazing, coordinated movement needed to be explained. because to create the movement of an entire region of the universe, something extraordinary is needed. It was assumed that in the direction of this flow there is a certain huge accumulation of matter, which, with its gravity, creates this flow. This is how the hypothetical great attractor appeared. And astronomers began to carefully search for the accumulation of matter in the direction of this flow. And it was discovered, and more than one. I will not list them or give details now. And at the end of the video you will understand why it really doesn't matter. Let me just say that these discovered clusters are not so massive as to cause a dark flow. In addition, there are no less massive clusters in other directions. But, even in the early stages of these studies, astronomers noticed that the magnitude of the dipole of radiation from distant bright galaxies differs from the magnitude of the dipole of the cosmic microwave background radiation. But there were not enough statistically significant studies to confirm this difference. And this whole issue remained controversial and unclear. And in the recent past, studies were conducted with a sample of more than 1 million quasars. And this study showed that the dipole of quasar radiation is 2.2 times greater than the dipole of the cosmic microwave background radiation. And the direction of this dipole differs by almost 28 degrees. In other words, research has shown that relative to distant bright galaxies, we are moving at a speed of about 1,000 kilometers per second, with a direction different from the direction of movement relative to the CMB by 28 degrees. And this discovery has baffled scientists. Why has scientists been baffled? Because if you try to interpret these results, it turns out to be some kind of nonsense. If we perceive the cosmic microwave background radiation as a global frame of reference, then we are forced to interpret the dipole of radiation from distant quasars as the movement of the distant visible part of the universe. Therefore, the following situation develops. Our galaxy, along with a huge number of galaxies close to us, are moving in the universe in the direction of a hypothetical great attractor, at a speed of about 600 kilometers per second. And almost towards us, with a difference in direction of 152 degrees, the rest of the visible part of the universe is moving, with an average speed of about 450 kilometers per second. More precisely, some part of the universe is approaching us, and some part is moving away from us. In other words, the global flow of most of the visible universe. Also, to some extent, a dark flow that includes the rest of the visible universe. I hope that you now understand the absurdity of this situation. Indeed, from the point of view of our understanding of the laws of physics and the properties of the universe, these two dipoles, taking into account the fairly high accuracy of our equipment, should have coincided in both magnitude and direction. And only in this case, we could confidently interpret the dipole of the cosmic microwave background radiation as our movement in the universe. But it turns out that this is not so. And it is not possible to explain the results obtained within the framework of the theories we use. But then how can this be explained? Let us assume that the radiation dipole of quasars is more accurate. Then we will have to assume that the cosmic microwave background radiation has an anomaly and is not isotropic. And in one part of the early universe the temperature is higher, and in another part, lower. And although the temperature difference is not so great, it is still necessary to explain this and revise the very basis, the Big Bang theory. Namely, all the theories and models that are the foundation of modern cosmology. And also, we will have to reconsider the results of all studies that used cosmic microwave background radiation. Another option. Assume that the result of this study is erroneous. But this does not solve the problem, since it will not change the very fact of dipole mismatch, which was known earlier, and which is also confirmed by more recent research. And the easiest way out is to simply turn a blind eye to this discrepancy. And this is an excellent example of how many discrepancies between theories and reality remain without due attention. Because most of you, right now, are learning about this discrepancy for the first time. And if we do not ignore this dipole mismatch, then we must admit the unthinkable. That most of the visible universe moves in one direction, at a speed of about 450 kilometers per second, which in reality is much more difficult to explain than the dark flow, because it calls into question the principles on which modern cosmology is based. Therefore, The authors called their work a test of the cosmological principle. And the absence of any rational explanation speaks of the dead end into which this whole story has reached. And the authors of the study do not find answers or explanations. The only thing they claim with high confidence, almost 5 sigma, that the dipole of the cosmic microwave background radiation cannot be interpreted as the movement of our galaxy in the universe. In other words, they reject with high confidence the kinematic interpretation of the CMB dipole. And this, in turn, closes the issue with the hypothetical dark flow, since it was part of this kinematic interpretation. And therefore, further searches for all sorts of great attractors or other hypothetical superclusters of any matter make no sense. And now, extraordinary ideas and solutions are needed to solve this riddle, and the authors of the work themselves talk about this, hoping for new physics to resolve this issue. One thing is obvious. That according to our ideas about the properties of the universe, we should have seen a complete coincidence of these two dipoles, both in speed and direction. Because according to the cosmological principle, the galaxies in the universe should not have such an orderly movement, and there should not be such global flows. Galaxies and galaxy clusters may have some kind of motion, but overall, on a global scale, the universe should be static, if you don't take into account the expansion. But it all looks like some unknown effect, or some unknown phenomenon, seems to be distorting the signal from objects in the universe. As was the case in the first case, when the movement of the local group of galaxies did not coincide with the CMB dipole. And we had to assume the existence of a dark flow. The same is true in the second situation, with a mismatch of dipoles. Something creates the illusion of movement of the entire visible part of the universe. Adding to the strangeness is the dependence discovered in one work, according to which quasars located near the plane of the disk of our galaxy have the greatest deviation from the CMB dipole, which suggests that it is not the anisotropy of the universe that randomly coincides with the plane of our galaxy, but the distortion of the signal from distant galaxies may occur partially or completely in our galaxy. I know that to solve this riddle, various hypotheses can be imagined. For example, the distortion of our universe under the influence of another universe. Or the reason for this is the hypothetical multidimensionality of our universe. And this contradiction in the data is supposedly the first clear evidence that the universe has more dimensions. Or we can even assume that the universe is a simulation on a supercomputer, and the observed contradiction is simply a simulation error. However, in the comments, you will probably find more exotic versions. But there is a quite logical explanation for this riddle. Explanation through the theory of moving space. And just the name of this theory can already suggest a solution to many. Because flows of space can distort signals from distant objects. And in the previous video on this topic, I made the assumption that perhaps this movement, the dark flow, is actually phantomic. Like a person standing in a river, he feels movement, but in fact he stands in one place. But in our case, it is not water that moves, but space. The speed of space, its acceleration or deceleration, depends on the location of accumulations of matter and voids, as well as on other factors. Voids are regions of the universe with a very small number of galaxies. And in order not to lengthen the video, I will not now tell where and why space moves. This is covered in previous short videos number 2 and 3. So, if the dark flow can be explained simply by the local flow of space, it is a little more difficult to explain the difference in dipoles. And I have two versions. The first implies a difference in the direction and speed of movement of space in two places. In the place where the light of quasars originates, and in the place where our galaxy is located. Let's divide the entire space of the universe into 3 conditional areas, depending on the distance. Near area. This is the region of the universe where nearby galaxies and galaxy clusters are located. Middle area. This is the rest of the visible universe, where light from bright galaxies and quasars comes from. And a distant area. This is a region of the universe that is no longer visible in the visible spectrum, but from there the cosmic microwave background radiation comes to us. The signal emitted from the distant area, as it approaches us, is influenced by the flow of space in the middle area. And with further propagation of the signal to the nearest part of the universe, it is already influenced by the movement of space in this part of the universe. And in such a situation, we receive a signal with different dipoles from the far area and the middle area of the universe. The disadvantage of this version is that it implies the existence of a flow of space on the scale of the visible part of the universe. And this is very difficult to explain. The second version does not require a global flow of space. But to explain it, it is necessary to assume that the cosmic microwave background radiation is not at all what we think. And it comes not from a distant part of the universe, but from all parts of the universe. And such an assumption is not unfounded, because the cosmic microwave background radiation has several still unexplained anomalies. For example, the so-called axis of evil, by some magical coincidence, is connected with the plane of the solar system. And don't forget about the Hubble constant, which does not coincide with measurements from supernova explosions. And by the way, this difference in the Hubble constant is at the heart of the crisis in cosmology. And in light of the latest discoveries about the early universe, it is even easier to believe that the CMB is not really like that. Because from the cosmic microwave background radiation we learn the exact age of the universe. But as we observe this so-called early universe, we see no clear signs that it is truly an early universe. And if this is indeed not the early universe, then the microwave radiation is not a cosmic microwave background. And if the age and size of the universe are much greater than we previously thought, then the radiation that reaches us becomes microwave may well have properties that should be inherent in cosmic microwave background radiation. And taking this into account, everything is described much simpler. There is a local flow of space in the near part of the universe, with a speed of about 1,000 kilometers per second, which explains the dipole of quasar radiation. And the dipole of microwave radiation is just the average value of this radiation from all parts of the universe. Therefore, its magnitude is similar to something between the movement of space in the near part of the universe and rest in the middle and far parts of the universe. But you may make a fair point, that in the universe there must be other flows of space similar to our local one. And it seems that this is the case. In one study on radio galaxies, the authors note strong deviations from the dipole distribution. They call this anisotropy, because these deviations have too large angular dimensions, and such large-scale deviations can be interpreted as large-scale flows of space, or as large-scale movements of galaxies, similar to our dark flow. By the way, it would be interesting to compare the position in the sky of these so-called anisotropies with the location of the irregularities in the cosmic microwave background radiation. So, these detected anisotropies, or supposed flows of space, when analyzing the data, may have influenced the result regarding the direction of the dipole. In other words, the difference in the direction of the dipoles may simply be an error due to the presence of space flows in other areas of the universe. This is also supported by the fact that in some subsequent studies this difference in direction was not found. In addition, in these studies the magnitude of the radiation dipole of galaxies turned out to be even greater, and it exceeds the dipole of the cosmic microwave background radiation by 3 times. I don't know how you feel about this interpretation of microwave radiation, but in this way it is at least somehow possible to explain the observed data. Moreover, this solution does not require the presence of a global flow of space in the universe. Therefore it is more likely. But it is necessary to explain the flow of space at a speed of more than 1,000 kilometers per second. Although, if we take into account the movement of the local group of galaxies, this will slightly reduce the speed of the local flow of space. There are also other possibilities to explain or reduce the estimated speed of this flow. But here it is important to note that the proposed solutions are very simplified, and they don't take into account many different factors. For example, the movement of space in the disk of our galaxy, which is probably responsible for the increased distortion of the dipole in the plane of our galaxy, is not taken into account here. And these solutions are more aimed at showing how the signal can be distorted due to the influence of flows of space. But the most important thing is that in the theory of moving space, this problem with 2 different dipoles is solvable. Like many other problems, mysteries and anomalies that this theory solves and explains. To be fair, It should be noted that if we reject the CMB as a source of reliable information, then within the framework of the classical theory of gravity we will again have to return to the use of the dark flow with a great attractor. Moreover, in this case, it will be necessary to explain the dark flow moving at a speed not of 600 km per second, but more than 1,000 km per second. And accordingly, the hypothetical attractor should be even greater than the previous one. If you are interested, you can find out more about this theory by watching the full playlist. The link is in the description and right now on the screen. And if you have your own version of how to explain this riddle, then we can discuss it in the comments.